Distance versus time graph. D stands for distance and T stands for time graph. A distance time graph shows how far an object has traveled in a given time. It is a simple line graph that denotes distance versus time findings on the graph.
Describing a journey made by an object is very boring if you just use words. As with much of science, graphs are more revealing. Plotting distance against time can tell you a lot about a journey. Let's take a look at the axis.
Where the distance and time located? Distance is placed in the vertical y-axis, while time is placed in the bottom x-axis.
As we can see, the arrow shows the direction of distance and time. The further to the right, the longer time from the start, while the higher up the graph we go, the further we are from the start.
Stationary object. If something is not moving, a horizontal line is drawn on a distance time graph. Time is increasing to the right, but its distance does not change. This graph shows an object that is stationary. In this perpendicular line, this shows that the object is moving at the constant speed. If something is moving at the steady speed, it means we expect the same increase in distance in a given time. Time is increasing to the right and distance is increasing steadily with time.
In this example, we can see that both the lines show that each object moved the same distance, but the steeper one, which is the green line, got there before the other one. So what does this indicate? A steeper slope indicates a larger distance moved in a given time. In other words, higher speed. The steeper the line gets, the faster the object is moving.
Curved line. Curved line on the distance time graph indicates the speed is changing. The object is either getting faster or accelerating or slowing down, which is decelerating. You can see the distance moved through each second is changing.
In this first example, the line is curving upwards. This shows an increase in speed, since the slope is getting steeper over time. In other words, in a given time, the distance the object moves is larger, which means it is accelerating. For the first part of the journey shown by the second graph, the object moved at a steady and slow speed. Then the object suddenly increased its speed, covering a much larger distance in the same time. The speed increased in the second part of the journey because it got steeper.
Here we have more examples. Example number 1. A car remains parked in a car park. As we can see, it is in a horizontal line, which means it is a stationary object. Example number 2. A runner runs at a steady pace to the end of a track, turns around and runs at the same speed back. And example number 3. A motorbike travels away from home at a steady speed.
How to calculate speed? To calculate speed, we can use the formula speed equals distance divided by time.
The graph below shows several stages of motion. In stage 1, we got 100 meter in 10 seconds, stage 2, 50 meter in 10 seconds, and stage 3, 150 meter in 20 seconds. Let us calculate the speeds of each stage indicated by the color. In stage 1, we got a distance of 100 meter and a time of 10 seconds. We divided 100 meter by 10 seconds and got the speed of 10 meter per second. Same as stage 2, we divided the distance by time, which is 50 meter by 10 seconds and got speed of 5 meter per second. And in stage 3, we got 150 meter divided by 20 seconds and got the speed of 7.5 meter per second. In stage 1 and stage 2, the object is moving away from the starting point, while in stage 3, the object is moving back toward the starting point and it comes back to 0. Let us have more examples.
So we have some word problem examples here. First problem, a man walks 20 kilometers in 4 hours. Find his speed. So the givens or distance 20 kilometers time 4 hours. So we will use the formula speed equals distance divided by time. Let's proceed to solution. Speed equals 20 kilometers, which represents distance, and 4 hours, which represents time. If we divide 20 kilometers to 4 hours, we will get 5 kilometers per hour, and this is our speed. So let's proceed to examples. Example number 2. A cyclist covers a distance of 15 miles in 2 hours. Calculate his speed. So the givens are distance 15 miles time 2 hours. We will use the formula speed equals distance divided by time. So let's proceed to solution. Speed equals 15 miles divided by 2 hours. So if we divide them both, we will get speed equals 7.5 miles per hour. That's all.